myself. So I graduated from Fremd in 2017, and then went to Purdue. Graduated in 2020, and now I'm at Microsoft out in Seattle. Um, and so at Fremd, I took about every AP class I could. Um, Came into Purdue with about 40 credit hours worth of classes, which I highly recommend doing something similar to that. So it shaved off like a full year of college for me, which is super helpful. Saved some money, saved some time. Um, and yeah, so I'm trying to think of. So here's some of the questions that Miss Denna was saying that you guys had, or just might be something that you guys would be interested in. So as far as like working at a big company like Microsoft, it's kind of weird. I've been here for 3 months already, and I still can't really tell you what it's like to work at Microsoft, if that tells you anything about how big Microsoft is. Um, so like, yeah, um, like the amount of things I know about Microsoft is tiny and ever growing every day. Um, and so that's kind of an interesting part about working at a big company is just how many things there are in the company for you to learn. And there's never going to be something that you're never going to know everything, right? Um, and it's kind of like working, it's kind of like a whole bunch of companies all under the umbrella of Microsoft. Like each team is very different. So like I have a very different experience than three of my friends who also work at Microsoft, also as software engineers, but in very different teams and therefore have very different experiences, um, just based on their managers and what they do and their teammates and their organization, stuff like that. So yeah, it's kind of a lame way to say what it's like to work at Microsoft, but it's pretty true. Uh, and then as far as internships, I had 2 internships with Northrop Grumman while I was at Purdue. Um, and so those were really fun. Those were actually something I got based on CTF experience, and that is Capture the Flag, which is a security competition that I got really interested in at the beginning of college. And then from that, my club was sponsored by Northrop Grumman, and they gave me an offer for competing in one of their CTFs that I did well in. And so that was like a really cool opportunity. I got to like go to there um, after my freshman year and help make a CTF, and then also worked on some of their internal tooling, and then came back again and got to actually work on some of their projects the next summer, which was really awesome. I really enjoyed that, except for the fact that it was in Cincinnati, which wasn't my favorite place ever, but besides that, it's great. But yeah, I think that internships are like a great time to like explore like different kinds of companies, different places to live, stuff like that. Like I've had friends who've lived all over the place. I've had a friend who lived in Provo, Utah, New York, LA, Seattle, all these different places. It's really like a really great way to figure out if you like a city or if you like being at a big company, little company, everything in between. Really great opportunity for that. Um, and that, and then interview process for uh, internships and full time is like pretty. It's I don't want to say it's rough, but it's like you're gonna get rejected a lot, basically. Like for example, my interview process for full time was, I think I started in like July or something, just because I wanted to get like stuff done earlier, at least get some. I wanted to have something early, and I didn't get like a my Microsoft acceptance until mid November or something like that. And before that, it was all rejections. Um, Everything from rejected from first round to rejected after an on-site interview. I probably applied to like 50 plus places, and the only 2 offers I had were from Microsoft and Amazon, and then a return offer from Northrop Grumman. So, like don't be discouraged by like rejections. And the same thing happened for internships. Like the only internship offer I had was from Northrop Grumman, from me like kind of proving that I know what they care about. And everyone else was reject. So yeah, just kind of expect to be rejected and always apply a ton and just keep on applying. And you can end up at like a pretty great place like Microsoft.
Can you explain like what the interview actually is like what they should expect, or how to?
Yeah, so it really depends on role, company, internship versus full-time, but generally internships, the only difference will be the amount of interviews you get. Like you might get one less interview or a slightly easier interview than what a full-time would get. But basically the process is typically for a software engineer, which is what I applied to everywhere. It's going to be, you know, probably going to be a coding interview, or at least some component of it be a coding interview where you're on a whiteboard, or since things are virtual now, it'd probably be like in some online like portal with a compiler or you know, the runtime behind it to go run your code. I don't expect to have like autocomplete or like IDE features. Typically it's just like off the cuff, like, do you know how to use the language without needing like, you know, compiler checking and stuff like that. And usually the problems aren't too hard or like not too terrible. They're not just trying to trick you usually. There's certainly some companies that do want to trick you, but by and large, that's not the case. Like for example, one of the Microsoft interview questions I had was reversing the words in a sentence. So like take like a sentence like, hello, my name is Connor, and then reverse it to be like, Connor is name Maya, something like that. So yeah, so and then, you know, depending on how you do on that, sometimes they'll also have just kind of a little bit more of an open-ended technical question, like if you were to design something, you know, like let's say that you had a piece of code and you were trying to figure out why it's running slow, like how would you go about that? Or, you know, just hypotheticals like that where it's not actually writing out code, but it's just kind of explaining what you would do in this situation, which they can't really easily present to you. Or in my Amazon interviews, I had 7 pieces of code that were slightly wrong. So they gave me the piece of code and the text of like what the intended, what it's intended to do, and then I had to figure out what was wrong with it and then fix it. So that's, yeah, so that was like a pretty interesting exercise that I hadn't seen at any other company. Yeah, so pretty much like, and then for Northrop, I did an interview. They just saw that I did well, and they were like, "Cool, you know, you've already proven that like you have the technical skills that we care about. So, you know, here's an offer."
All right, let's pause for a sec. Does anybody have any questions they want to ask about what Connor's talked about so far? That awkward moment of silence.
I have a question.
All right, let's hear it, Philip.
Like at Purdue, like how were like the courses in college like compared to Fremd, and even just like in general, like how were the college coding courses?
Yeah, for sure. So my first course at Purdue, so the Purdue CS curriculum is you start off with CS 180, which is a Java course, and so I ended up taking this course because I think I ended up getting a 4 on the AP test somehow, and they needed a 5 to pass 180. And so I took this course and kind of knew everything going into it, more or less. I think I still learned some things for sure, but by and large, I was prepared from APCS and from being a teaching assistant with Ms. Dunna senior year. So it's kind of the same kind of questions that you'll expect to have APCS, where it's like, is this a compile time error or a runtime error? All these different, really, really nitty gritty details of Java. Like if you make two strings that are the same contents, if you do like string 1 equals string 2, are they actually equal? And it's yes, because of string pools and stuff like that. And so that course was more or less like what I would expect of a CS course coming out of Fremd. And then let's see. So then that kind of allowed me to like start studying and like I got interested in like C and assembly and other stuff like that. So like super low level languages, which is also what we use later on down the line at Purdue. Or at least you'll have 1 or 2 courses in C, and then you'll have one course that deals a little bit with assembly. And so through that, I was kind of like really well prepared for my future semesters, and then kind of kept running with that, where I would be interested in stuff and then learn about it before I actually took a course on it, just because I was actually interested in it. This wasn't true for everything, but it's true for a lot of the courses I took. So that really helped out. But yeah, Purdue classes are definitely tough. Definitely have to like study, sit down for a while, understand stuff. A lot of, it was really helpful. I had a few good friends in the program that we would just like always study together, and that's like always a really good way to make sure that you actually get studying done, because in college there's like no one telling you that you actually have to go study or have to do anything really. No one's sitting there telling you to go to class, or even telling you to go, hey, you haven't even eaten breakfast yet, go eat breakfast. Lots of just figuring out what works for you and like how to do stuff. So it's like, I would just suggest like being really diligent about at the beginning, just like getting into like good habits of like studying ahead of time, and having a calendar of like, this is when my exams are, and like generally you'll know when exams are at the beginning of the year, more or less, or at least you'll know like what week it'll be. And topics, the syllabi are pretty detailed and pretty good about explaining exactly how things will be covered and at what pace. Yeah, so let me think about like, so first you start with APCS, or sorry, CS 180, which is Java. Then you go into CS 240 and 182. So that is discrete math, which is kind of like summations and all the other pieces of math that are very helpful for like, like analyzing algorithms and kind of just dealing with a lot of things that are, tangential math to CS. And then CS 240 is our intro to C programming. Then you go into 250 and 251, it's our architecture class, and then our basic data structures and algorithms class. So that's where you'll learn about stuff like, sorting, like insert and sort, bubble sort, merge sort, different things like that. And then different data types that are, helpful, like heaps and lists and queues and stacks, and kind of the basics of like a lot of things that you'll see come up in coding interviews, that are things that get used in coding interviews. And then you go into 252, which is our systems programming. So that's again in C, and is like the low level, like, how to go make a HTTP server, go make a shell, which, oh yeah, that's the other thing about Purdue and college, is like using Linux, and command line prompts is like ubiquitous pretty much, at least at Purdue, and it's kind of in general a good thing to know. So that's something I picked up as I got to Purdue, and it's been super helpful. Now like my laptop only runs Linux, and my desktop is my Windows machine. And yeah, it's super great to learn. But yeah, so overall, Purdue is definitely tough, but I think it was really worth it for me, at least. Learned a ton, and it's really like what you make of it. Like if you just do classes and you do nothing else outside of that, and you'll probably like, like I would still have benefited from the degree, but not nearly as much as I did from doing like a whole bunch of extracurricular stuff and doing CTF. That definitely like turned it from like just a degree to like a really good investment. Does that answer your question about Purdue?
Yeah, thank you.
Connor, I just sent you a question in the chat that was asked by a student.
All right, what do you wish you knew about CS as a senior in high school now that you have majored and found a job in CS? I don't know. Let's see. I don't know if there's much like. There's certainly things I didn't know, but I don't know if I think I kind of lucked into like I was really interested in computer science and coding, and then it turned out when I really got into it that I really liked it. So I think I kind of lucked into stumbling into the thing I would learn to really enjoy. I don't know if there's much that I like now that I have a job that I like regret or anything. I also had a lot of upperclassmen friends who were really helpful about like what classes you should take and what kinds of things are like good to do in what order because of like for example I took our algorithms class, our like full-fledged algorithms class as early as I could to prepare well for interviews and for interview questions and stuff like that. So it's just like things that you wouldn't normally think about that they kind of realize are like really important. So in that way, I was like really lucky to that they were there to kind of guide me on like, oh, like these are some good ideas. So yeah, I don't know if I really have much for that question, unfortunately.
Real quick, I just want to reiterate what Connor said about the algorithms and data structures class. Every student that I have had come back and talk has said that that was one of the most fundamental, important courses they took. So they've said that it's been crucial for interviews, crucial for internship success. So so like he said, that is a course that you want to make sure that you do not screw around in, and that you, like he said, take sooner rather than later. And then I also sent you 2 more questions that came through the chat. So what are the basic requirements to get into Purdue? And can you talk more about Capture the Flag, what it is it at all schools?
Yeah. So basic requirement to get in Purdue, I honestly don't know, and it might have changed since I got in, but I think, let me think. So I got like a 34 on my SAT, had like a 4.7 weighted, I think, something around there. And had taken, did well in all of the CS and math courses more or less. And I took like physics C. I finished out at Calc AB or Calc BC, sorry. And so I got in based on that. I don't honestly know how competitive it's gotten. I know that like it's definitely gotten more competitive since I got in. I assume that probably looking at their average statistics over like for the past year is probably the easiest way to kind of get a sense. But I know that CS is definitely getting way more competitive just because of how many people have been applying and how many seats there are in the program. And then as far as CTF, so Capture the Flag competitions are these security competitions that unfortunately they're not at every school, but they are all hosted online. So, even if there's not a team at your school, you could play with some other team or kind of go on your own, which might be tough, but you could do it. But anyway, so the competition is basically most of the ones I play are Jeopardy style. So there's different categories and there's different difficulties of problem. So the typical categories you'll see is web, cryptography, Pwn, which is kind of like exploit development stuff, and then reverse engineering, which is you have I'm going to give you a compiled program, and then there's some secret held in it, and you have to go find that secret. And so that secret will be the flag, and the flag is just a piece of text that proves that you solved the challenge. So for a website, it might be that there's an admin portal where there's some vulnerability with the login, where like there's a problem where if you put in some certain sequence of characters, it will bypass the login, and you can log in as the admin, and then on the admin page, there's the flag. That's a simple example of a challenge, like an easier challenge. And then for cryptography, it could be something simple like, maybe cryptography is not my strong suit, but you'll have challenges that are super easy that are like maybe like someone just like took a string and then coded it in some really weird way, and you have to go decode it. That's like a super simple example, and it gets to much more crazy, hard, and gets very math intense very quickly. So like sometimes you'll just trying to break RSA or AES, like they'll implement it slightly wrong, and then you'll have to use that slight imperfection to go and recover the flag. And then pwn is like, I give you a vulnerable program, you find a way to run arbitrary code on a server, and there will be a flag file on the server that you have to go read, basically. And then reverse engineering is there's some secret held in the program, and you have to go find it and figure out what it is. So that might be something like there's some random data held in memory that's encoded, and you see that there's an encoding function but not a decoding function, and so you just have to figure out, you have to reverse the encoding function and then run that on the data, and then you get the decoded data, stuff like that. Let's see. It's not at all schools, but a lot of big schools have them. Like most of the Big Ten schools have a CTF team, and like I said before, you can you're able to play on different teams or whatever. Like I've got a few people I know at Purdue who don't play on the Purdue team because they're really, really good, and they play on like one of the top 10 teams in the world. And then how does Honors College at Purdue offer from the normal track? So Honors College in college, for by and large at Purdue, it's viewed as like it's nice to have, like, you get like priority registration and you get to live in a specific dorm on campus that is like way closer than most of the other dorms. But besides that, most people don't really, I don't know how companies value it, but as far as like students, it seems like most of them aren't super interested in it. Other than that, it requires you to do a lot of extra work, and Purdue is already a tough college, and it's certainly not something where I feel like if someone graduated from honors college and I graduated normally, that I feel like I'm at a disadvantage in the interviews, because like whatever time they would have dedicated to like extra classes, I dedicated to like things that you can't get inside of a classroom, and in that way I think that like my decision was better, at least for me. And I think other people would probably feel similarly. Question about honors at Purdue: what does it offer different from other colleges? Is it worth it? Yep, so just got that one. Are there any other questions right now? Oh, that's another thing I did a lot of is independent studies. I did 2 or 3 maybe, and that's like a really great opportunity to try to get things that you can't get in normal classes. So I did a malware forensics and incident response class. So that was all like reverse engineer malware, and then figure out how to you know do digital forensics and incident response, where it's like there's some malware on a machine, go figure out what it's doing and what it's done to the machine and how you can go and get it off the machine and stuff like that. I really enjoyed that class. And then I did a few classes on reverse engineering and exploit development. So those were things that are really hard to get in a classroom and get credit for, but that I was able to get through those independent studies. Talk about being a TA. Oh yeah, I was also a TA in college for 2 years. So I can talk about that as well. Yeah, so for as far as like being at Purdue and being a TA there, it's kind of, it really just depends on what the professor wants you to do and like how many people you have. So like classes that have like the core classes have like a crap ton of TAs. And so most of the undergrad teaching assistants have, their job is to kind of go to labs. So a lot of classes will have like a 2-hour lab component where it's either you have an assignment to do in lab, or you just can come into lab as like an office hours kind of thing, just to ask questions about whatever the current homework or project is. And so the UTAs are there just to help answer questions and stuff like that. There's also, in my first semester as a UTA, I did some style grading. And so this was like, we had a code style guide for the class, and then we had UTAs grade that and ensure that students' code like matched the style guide. And so this was like a way for students to get like an easy 20 points, even though a lot of students would screw that up. But yeah, it was fun. Very tedious, but
Can you
yeah.
elaborate on what you mean by the style guide and what things students did to screw it up?
Yeah, so I mean, this is very specific to our style guide, granted, but basically the style guide was like, hey, for an if statement, make sure to have a space between the if and the opening parenthesis of the condition, and make sure that the opening brace of the if statement is on the next line and not directly after the condition. And make sure your includes, or your, what is Java imports? I think Java's imports, right? Okay, yeah. So like, make sure your imports are ordered in this way. It was in C, so it was includes, but it's the same idea. Make sure they're like alphabetical, and there was like kind of like 3 classes or 3 kinds of imports. It was like your standard library stuff, things that are, it was like standard library, things that you created, and there was another one, and I forgot what it was. But either way, so there's a lot of it was just students not reading the whole guide and being really diligent about it. It was really easy to kind of miss something, and this is very specific to one professor at Purdue who does this, which I think is a good thing to know. But students would argue otherwise. I still think that having, like, being able to follow a style guide is like very good, just because, for example, if I go look at code on my team, we don't have a style guide at like a formal one, and so all the code kind of looks similar, just based on like everyone, like based on code reviews, making sure that things look nice and like how they should be. But there's definitely sections of the code base that I look at that like are different and like are actually harder to read, because they're different, and it takes me a second to like I can't just automatically parse out all of the code in my mind. I have to go actually read some of it, because it's not formatted the same as other pieces of code. And so that's like one of like the paramount reasons I see for like having a style guide and actually caring about that kind of stuff, even though in your freshman year of college, it just seems kind of dumb, because you're the only one that you've only ever really read your code, or if you read other people's code, it's not a huge ginormous code base that you don't understand at all. So yeah. And then as far as like grading and anti-cheat and whatnot, grading is typically done with a set of test cases. Like for that class, we had a really nice randomized test case generator, and we would just run your program like hundreds of thousands of times and make sure that it always worked. And so that was like that's probably the most rigorous testing you'll get. Other than that, it was usually just like a set of private test cases that are run. Sometimes you're given the test cases, sometimes you're not. Sometimes you're given some public test cases, but with the knowledge that there's private ones that cover more functionality or cover it a little more in depth and check like, you know, maybe the public cases check like just like basic functionality. So stuff like that. As far as anti-cheat, we use MOS, which is a Stanford tool that you submit all the students' code, and then it does some magic that they don't tell you how it works because they're scared of people circumventing the anti-cheat, and they figure out how similar two programs are. And it does this at binary level so that like things like variable names and stuff like that just don't matter. It might work at both levels as well, just to see. But yeah, and then you can also like, one of the things that one of my friends built was a tool to do a relational graph across projects that will cluster students who have similar projects. So you could easily find like, even if things were like only slightly similar or like similar enough where it was like kind of weird but not that weird, if you saw that over multiple projects, you could build up more of a case for cheating. So that was an interesting
And then
project.
a follow-up question on that, and then I just sent you another question in the chat. So let's say they did catch somebody cheating through that, or this cluster which you talked about, which is super cool, by the way. What would then be the consequence?
It totally depends on professor and how bad it was and stuff like that. But anywhere from like you get a 0, it's basically assumed that you get a 0 on whatever it was. So whatever you cheated on, you basically get a 0 for automatically, and then depending on how egregious or how many times you've done it, it may lead to expulsion. It's definitely not something that you want to screw around with at all. So like the professor I had like, you know, his ethical standards are extremely high, and so I mean, as they should be. So you know, whenever he saw cheating, he wanted them out of the program more or less if it was egregious. Yeah, so definitely don't screw around with that, especially in college. Not fun. Let's see. Oh, how did you come up with ideas or areas of focus for independent studies? So this is, again, just things I was really interested in. So these are things that I'd kind of you know, I was doing outside of school already, and I wanted to explore that further. But like, you know, you only have so much time in the day for other stuff when you're in college and have you know, all your classes going. And so my way of ensuring I did those things and also getting credit for them was to do independent studies. But yeah, so like all those things were just like the reverse engineering exploit development comes straight from my interest and participation in my CTF team. And the reverse engineering of malware is again from that. It was very much just like I saw that we had no reverse engineering classes that I could take reasonably. We had one that was a grad class that was not being taught anymore by the time that I would have been ready to take it. And so yeah, so that's basically where I came in with independent studies. But I'd suggest doing it no matter what. There's always going to be some area that you find interest in that won't have classes associated to it, or it might have classes that don't go as in depth or are really hard to get into, or whatever the case may be. And then when you applied for an interview, were you required what is it? When you applied for an interview where you required 2 or more coding language when the interviewer tested you, could you choose your... Oh yeah, so for interviews, you're able to choose whatever language you want to use. So like, I don't know, like you could use OCaml if you wanted to. Like it's a random functional programming language that would probably be really painful to use, but you could do it. Yeah, in general, people don't care what language you use. There's a few places that are like really specific about what you use, like Jane Street. It's a financial institution. They are I think it's a Haskell shop. So they're pretty specific about that. But by and large, no. I never had to code in one specific language. I was always able to pick for all of my interviews. And so yeah, it's just a matter of like getting comfortable with one language. So for example, like at Microsoft, all of my programming is done in C#. I've never touched C# before stepping into Microsoft. I've always done C++, C, assembly, Python, Java, Scala. Had never touched C#, hadn't even seen C# code before. And so yeah, it's really just a matter of like, do you know how to program? And if you can program in one language, we trust that you can learn to program in this other language, because by and large, like the hurdle is syntactic things, not how does this, how to code. That kind of translates pretty well between languages.
All right. Does anybody have other questions? If not, I have some to ask, but if nobody else, but I want to give you guys a chance first. All right. So, and those of you that have been sending me questions in the chat, that works perfect. So if something comes up, you can always send me a question in the chat, and then I'll just send it on to Connor, as well. So one thing that I wanted you to elaborate on is if you can just kind of talk about, I know right now might be different because, of COVID. I don't know if you're working from home or not,
Yeah.
but if you can just talk about like the dynamic of, what is your team like, your project manager, how many people, what's the workflow like when you're given a task, how much time do you have, like just kind of like, how does that work? Are you tasked out with a timeline? Do you make your own timeline? Just kind of just explain that a little bit.
Yeah. So once again, Microsoft has 1,000 companies within a company, so it's varied greatly even within Microsoft, and it'll vary greatly across companies. But for me, I have a overall team of like maybe 30 or so, that maybe even larger. That's like my overall team, and then I'm on a feature crew, quote unquote, and that feature crew is about 7 people. And so, we're tasked with doing things that are, each crew has a specific area of our tool set that we like develop in, or that we care about. And so like my first project on the team was to go take some code that's like 5+ years old and make it new and better, and make it compatible with some new requirements that we have for security. And so that project was basically like someone new on the team had already started designing it. And then when I came on board, I helped finish that design, get that design approved by the rest of like the senior members of the team, and then scoped out. So that entailed like getting like scoping out, how much time do we think this will be? What are all the things we need to do in order to get this from this doesn't exist to this can be deployed? And then actually started working on it. And so that's an interesting process. It's a lot of, the task we were given was, this thing needs to work just like the old one does, except better. That's kind of the input we had. We don't want to change any of the external interactions. So however people used the tool before should stay the same, but behind the scenes within the tool internally, it should work way better and hopefully be less painful to use. And so that's where we started. And then basically we figured out how the old tool worked inside and out, and then decided on the new design, given like we want to make things easier for us because we have to be administrators for this tool. So we wanted to make that workflow a lot easier than it was currently. And so like basically like good things to ask are always just like, what is the goal here, right? Like, is the goal just to make this faster? Is the goal to make this more automated? Is the goal to just meet those compliance requirements and nothing else? Do we want to do a full rewrite here, or do we want to take the code that already exists and just modify it a bit? Like these are all like good questions to ask about or to understand about whatever project you're doing. Because like, for example, at first when it was just one person working on the project before I came on, the plan was just to rewrite port parts of the code, because doing a full rewrite would be really hard with just one person and under the time constraint we had, because this tool needed to be done before a specific date. And so then when I came on, the scope changed to be a full rewrite because we had the 2 times the manpower to go do that and get that done. But yeah, so that's I don't really get like so far all my tasking, quote unquote, has been self-driven, with the overarching task being get this done, and not almost no not no oversight, but my day-to-day is pretty much like, if I showed up to meetings and did nothing else, no one would immediately know except for the fact that I'm working with someone directly as a partner in this project. And then someone would know at the end when like I didn't deliver something on time. But it's again like a lot of freedom, just to like, people trust you to get stuff done, just get it done. And I'm always reaching out to random people across Microsoft for like, hey, how does this work? Or like, why is this way? And where are the documents for the documentation for this? And I always have questions. So never be afraid to like reach out to people and ask even quote unquote dumb questions, because everyone starting out, especially at a big company like Microsoft, realizes that like there's just so many things to learn that it's you can't expect someone to know them all or even know the basics of them all. Is there a standard for documenting work? Not formally, at least at Microsoft, but there's definitely a big push to make good documentation, and especially for like, so for example, like we have private clouds and stuff. So we want to, we've been pushing for really good documentation so that we can have those, we call them troubleshooting guides, TSGs. So having those TSGs well written and make sure that they're available for anyone who has to fix problems in a private cloud where you might not have as many people can get access, or you have to physically be somewhere to get that done. And so yeah, there's a big push for having good documentation, but I haven't seen like this is how you document things at Microsoft. I don't think that really exists.
So right now, on a day-to-day basis, like what would you say your day-to-day has been your last few weeks, months working there?
So my day-to-day, now that I have my project, so for example, like my first few weeks were like meetings and training was basically what I did. Mostly doing the training out of not having a project to be tasked on, or was waiting on the design to kind of get reviewed and get feedback. So me and my teammate would come up with, here's the newest iteration of the design, and then we'd have to wait for a design review meeting or just like an email from some of the senior people giving feedback, and then we'd kind of go reiterate. But while we were waiting, I didn't really have much to do, so I just did a bunch of training. And then recently, since going into like the development phase of this, my days are, on a weekly basis, it's probably about 10 hours of meetings, which is kind of it's on like the higher side of like how often you'll see meetings probably for like starting independent contributor like me, as opposed to like managers and team leads and stuff have like way more meetings. Like my team lead yesterday had 7 meetings, and he's basically slammed with meetings all the time. So just kind of depends on who you are, but so starting out 10 hours is like kind of a lot, but that's about what I'm at. And then the rest of the time is spent developing, or there's definitely things that crop up every once in a while where it's just like, oh, a new training has come out for standards of business conduct, or different random trainings that are mandated across the organization or company that you have to get done. Or maybe some teammate asks you some question, or maybe some teammate has, maybe you have to ask a teammate some questions. And so, it's just kind of, those other 30 hours a week are a lot of just working on, getting that project done, with some other things mixed in there for sure. Like I'm not just spending 8 hours a day coding. I would die if I did that.
All right. Do we have any other questions? What were some factors that you decided when you were choosing between your job offers that you were given to help you decide where to go, if you wanted to relocate, et cetera?
Mm-hmm. Yeah, so I was very adamant about relocating. And I didn't honestly have too many options, or at least not options I was willing to take. So like I had a return offer to North Grumman, which was, again, like I talked about, in Cincinnati, and I just didn't really love Cincinnati. Didn't really want to be there. Kind of really wanted to get out of the Midwest. So that was like goal one. So everywhere I interviewed was for elsewhere. And then I chose interviewing in Seattle because I had a slew of friends who graduated a year early who all got out to Seattle. So Seattle was kind of the goal from the start. And then I had, eventually got my offer from Microsoft and from Amazon. And Amazon refuses to negotiate on, well, they say they refuse to negotiate on offers, at least for entry level. And so the offers I initially got from Amazon and Microsoft were pretty much the same, more or less. I think Amazon was like slightly better in one way, but worse in another, so it kind of evened out. And so then I negotiated with Microsoft to get bumped up to a higher level, be brought on as a level 60 instead of level 59. And so definitely negotiate with whoever will allow you to. I think Amazon is the only one I've heard of who just point blank says that we won't negotiate, we don't care, which is a weird take, but I didn't really want to work there anyways, if I'm being honest. Yeah, like all of my friends I've had multiple friends who've worked at Amazon, and they either love it or hate it, just based on, it's kind of as far as I've understood, it's kind of like a sink or swim kind of place. Like they're okay with letting you sink, but if you swim, you'll do really, really well. And then as opposed to Microsoft, where it's much more, wanting you to succeed and stuff like that, and not expecting the world of you at the very beginning. I've really enjoyed my time at Microsoft so far, but then again, I'm only 3 months in.
I have a question.
Yep.
So what would you say, like, from time spent between high school and to where you are now? What would you say is your biggest roadblock?
Your biggest roadblock?
Like roadblock, like
Hmm.
biggest like stumbling point.
Um, I don't know, honestly. I'm trying to think of like, um, there are definitely points where I thought that I was going to stumble. Like for example, I took a grad compilers course, and that was definitely like the hardest class I took at Purdue, and it's known as one of the hardest classes at Purdue. But it's also probably one of the courses that I am the most glad I took because of how well it prepared me for like ambiguous things. So this class was, you know, um, we'd be given a project that has like a whole bunch of skeleton code, um, and it was in Scala, which um, the expectation was that you hadn't seen Scala before, and they didn't teach you how Scala works. And so you were learning a new language while trying to understand how this program works, and then the specifications on how the program should work and how this compiler should work um, were through this very formal notation that wasn't in code. That it didn't translate. It translated to code, but you had to figure out how it translated. Um, and so like it was given in like a very formal mathematical notation of like they'd give you type rules. So for example, like, you know, one of the things we had to do was just do um, checking on types, a semantic analyzer. So checking that like does it make sense to do a comparison between an integer and a Boolean? No. So that's something a semantic checker would semantic analyzer would check. Um, and so they would give you these really formal rules of like, uh, you know, if you have an integer being compared to an integer, the result is a Boolean. So like 1 == 1 results in true or false, you know, or x== y, where x and y are integers. That makes sense. But you know, Boolean a comparison between a Boolean and an integer doesn't make sense, and it's a semantic you know, failure basically. Um, and so this course was like probably the hardest, and I almost failed it. Ended up not, barely. Um, but yeah, that was probably the closest I came to like stumbling at Purdue. But it still is like probably the class I'm the most glad I've taken, given that I passed it. Because like for example, like the project I was given at Microsoft was like relatively ambiguous, and that wasn't very scary to me because of doing all these projects that were like super ambiguous. Had, you know, it's not that I had no clue if my programs would work. Like there's definitely a path to getting 100%, but it was like a lot of just reading and understanding what it's doing and what it's trying to do. And that's what a lot of your time was spent on. The actual code to implement this stuff was relatively short, and everything was there for you. You just had to understand how it works. So that was a pretty unique experience that I really enjoyed. It reminded me a lot of being in like, to some degree, physics C is kind of like this, where um, you know, it's not like hand holding, like just like here is an equation and then you apply the equation because I told you to. You know, it's like here is an equation that you know of, and here's a problem that involves like 2 or 3 different things chained together. That's, you know, it's not just a direct like, you know, apply the algorithm we told you to, or the, you know, this is a that problem, you know. Um, there's a little more to it and a little bit more thinking involved. So that's like the closest parallel I can draw to that might, uh, you know, resonate with you.
All right. Do we have any other questions? You probably have time for maybe one more. All right. Well, thank you so much, Connor, for joining us. We really appreciate you shared so much amazing information with us. And if anybody has any follow-up questions or things that you think of later, I can always, I'll put together, I can put together some questions and ask him if he has any other insight to share. So last chance for questions. Anybody?